Welcome to this RAD Server deep dive webinar. This time we're going to go inside the department store solution that we introduced in the RAD Server launch webinar a few weeks ago. Our agenda today is we're going to talk about thinking in terms of services and service architectures. Then a quick overview of RAD Server, the product itself, some demonstrations. Then we're going to talk about scenarios for RAD Server single and multi-site deployment of your applications, and then we'll take your questions at the end. We've got a full team of presenters on today's webinar. First, I thought I'd start with a conversation with Michael Swindell. Hey, Michael.
Hey, David.
I thought it'd be great to have you talk to everybody about thinking in terms of services instead of applications.
When we look at the RAD Studio, the Delphi customer base, and we look at the business solutions that a lot of our customers have built over the years and are maintaining today or evolving, most of them fall into two different categories. They fall into kind of a classic client-server architecture where we have more of a thick client, often a Windows client, with a RDBMS backend, either SQL Server, Oracle, DB2, etc. And these represent the majority of the established applications that have been around for a long time and our customers have been very successful with. Developers have been able to build solutions for a wide variety of industries in healthcare, manufacturing, retail, and they're deployed in just about every corner of the world and just about every vertical market. And then we have a category of customers that have been building multi-tier type of applications, N-tier solutions, most commonly with our Data Snap toolkit, where the clients are thinner and there's a middle tier that contains business logic and database access and connection pooling and things like that. This has been a popular architecture, but we'll talk a little bit about why a more services-based backend is really a better backend for 2016 and going forward, and more contemporary, and kind of also can help companies really expand their business and create a lot of flexibility both for their development teams, but also for their business. Now, if we look back at the classic client-server customers, some of the things that they go through in their business is when they are selling and marketing their solution, for a customer to spin up a trial, for example, or an eval of a solution. Let's just use a dentist office as an example. We have a number of our customers build dental and healthcare type of office solutions. It's in a classic client-server architecture, it takes a lot of resources to spin up an evaluation or a trial for an end customer. They need to download the solution, they will need to set it up and install it on site. They often need to have a database set up on site. When we're talking about a three-tier architecture like a Data Snap type of a solution, they also need to do that as well. They need to set up that Windows server on site. Today, most end users or most customers looking for a solution want to try something out on the web. They want to be able to, log onto a website, fill out a form, click on something, and spin up a solution instantly. And the classic architectures don't make that easy. It's possible to achieve some of that with VMs on the fly in Amazon and things like that, but it's not something that is very easy to do from a developer or a business perspective. A lot of the modern newer frameworks and platforms that have come out almost every month, most are geared more towards this type of elastic type of business model where you can spin customers up very quickly and transparently. And that helps you sell faster because customers can now try out your application. If you sell it, you don't have to be on site or send technicians out to install them to make the sale. So this type of approach is really gaining a lot of traction, and a lot of our customers want to move towards this type of elasticity. And in order to achieve this, a more services-based architecture can help developers and help businesses achieve this. If you can move the business logic out of these more tightly bound tiers into a more services-based backend, then you're providing a lot of flexibility for hosting the backend. It doesn't have to be hosted on site. It can now be hosted in any of a number of cloud infrastructures like Amazon or Google or Microsoft. We're also providing a lot of client-side flexibility with services-based backend. So now we can build the preferred rich client experiences, but we can also provide alternative user experiences, maybe lighter weight web experiences or mobile experiences. And we can also integrate other teams as well. So the classic, Delphi built application is Delphi technology on the front end and on the middle tier and on the back end. By moving to a more services-based back end, you're really opening up the solution to other teams. You may have other teams in your organization that are using other toolkits, other languages. From a business perspective, this is highly desirable because that team might already have a solution, and expertise in a particular area that you want to wire into the Delphi solution. If we talk about the dental office application, there may be a team that is building the business side application. That's the patient application with a rich front end in Windows and some mobile clients. That same organization may have a whole nother team that specializes in the imaging equipment and imaging interfaces. And they may be an acquisition, and they may have expertise in code and technology in completely different languages and frameworks. So by using a services-based backend, we can couple in other technologies and teams in a much more flexible way.
I know you've been talking with a bunch of our customers as part of building up the strategy and the solution with RAD Server. They're interfacing with insurance services, payment processing services, things that may even be outside of their own architectures, right?
Exactly. So what we're steering towards with RAD Server and specifically with services-based backends is to think about your application differently. So rather than think about your application as a front end and a back end, to think about the functions of your applications as a collection of services that can be available for integration to various clients or from web applications. By putting them into services, you're giving yourself and you're giving your business the flexibility to adapt to new technologies, to acquisitions, to new product ideas. And so this is something that most of the customers that we talk to today, I would say the majority of them have some type of services-based initiative, which is either introducing new services or it's transforming their old business logic or their older applications into a more services-based architecture. What we wanted to do was to make this easy for our customers, to make it easy for you to take older applications and older code and be able to repurpose that and migrate that into a services-based architecture. And we wanted to be able to do this so that you didn't have to throw anything away. You can reuse everything that you've invested in over the years and migrate to this into a services-based architecture. If you're spinning up a new application, we all know that Delphi and C++ Builder are the fastest ways to develop business logic and applications. If you're building a new application, we want to encourage developers to use the fastest tools available, Delphi and C Builder, to build these types of applications and services. So RAD Server works for both. It works for new applications that you're going to spin up with completely new code, and works well for migrating existing code either from 3-tier architectures or N-tier architectures or client-server architectures into this services-based backend.
I put up Martin Fowler's microservices landing page. There's lots of information there. I put some of the listings that he had on that page for common characteristics. And I think developers on this webinar will look at these lists and say, that's what I've been doing with Delphi. That's what I've been doing in C++ Builder. I've been not only using components, but I've been componentizing my applications into reusable objects, into business logic, into data snap servers, remote methods, and so on. And now with RAD Server, all of these kinds of things.
Yeah, I mean, the concept of services is very similar to the concept, the original concepts that we had with components, where we're packaging functionality into very easily consumable components. The difference now is that rather than being tightly bound to into your rich client application or tightly bound into Delphi, by creating these services with very interchangeable standards like REST and JSON, you're now building these services that can be consumed by virtually any type of application or language or framework. So it's really providing a lot of flexibility and helping you really get a lot more value out of the code that they're building, or the code that you've already built, and you want to take it forward into a more flexible arc. It's very extensible. It also supports both a microservices based approach, which is really breaking. It's pretty simple, just breaking the services down into individual packages for each endpoint. And RAD Server supports that, and that can provide you with a lot of flexibility with scale, and scale and failover, and works very well with today's web architectures, especially certainly today with IIS and all of the scale and failover capabilities that are part of that architecture.
So, Michael, at the RAD Server launch webinar a few weeks ago, we did an introduction to RAD Server and some pieces and parts, but I think it's good to go quickly through again an overview of not only what RAD Server is, how do you think about developing for it, and also what's included in RAD Server.
Sure. So I think there's really three key components to RAD Server, or three key pieces of functionality. The first is REST endpoint publishing. And this is kind of the services part of the services architecture. And what that means is we're taking business logic written in Delphi or C++, and we're plugging it into RAD Server, and RAD Server is then publishing publishing REST endpoints that can be consumable by virtually any type of language or framework. So that's kind of its core piece of functionality. The next is integration middleware. So built into RAD Server is integration with RDBMSs based on the FireDAC technology. So if you're familiar with FireDAC, and that is part of RAD Server, where you can do connect out to SQL Server and or Oracle, IBM DB2, MySQL.
Or even other services as well, right?
Correct. Cloud services, also integration with IoT devices as well. So we have a framework for connecting in Bluetooth and Wi-Fi smart devices or IoT devices into the RAD Server backbone. And there's a whole edgeware component to that so that you can locate these anywhere in your business location. And then the last piece is application services, and this is about providing out-of-the-box functionality. So not just taking the code that you write and putting it and publishing it, but RAD Server has a set of functions that are built in or pre-built functionality that's available to you use in your application. In fact, if we go to the next, move to the next slide, kind of part of the development lifecycle of a RAD Server application, some of these pieces are part of those application services. So things like user management, push notifications, even simple JSON data storage are all services that are provided out of the box in RAD Server. And it's a very simple life cycle of creating your server endpoints from your code, integrating with your backend database. If you want to make it really lightweight, you don't even have to use a backend database. You could use the simple JSON data store that's built in. But I think most customers will use the SQL, a more powerful SQL type of data store. And then adding application services. So one of the more popular things in RAD Server is the user management and user directory services. So there's a full user management and authentication system built in with access control, et cetera. So you can create users and authenticate, and they can authenticate, and then you can control which users and groups have access to which APIs and parts of the applications. And then it's very simple to deploy. It's a very simple system to deploy. RAD Server is an application itself, so it's not something you build like back in the DataSnap days. It's a server, and you load your modules into it. It has a management console that you can add users, manage your services, and also monitor and analyze them. So there's a full analytics engine built into the server that measures and reports on all of the API utilization and access to your application. And then, of course, it works very well with VCL and FireMonkey for building rich client applications that will connect and consume these services. So you can build Windows, iOS, Android, or even wearable, Motorola, and Samsung wearable devices and Android devices. But being REST-based and REST JSON-based, you can also use other toolkits and languages. So if you have other teams that are using other languages or frameworks, they can consume these services in Java, C#, Python, JavaScript. And that means that it plays well with web technologies as well. So web teams using things like Angular and JavaScript and HTML5. So EMS was our launch of our services-based backend, and EMS stands for Enterprise Mobility Services. EMS was recently introduced and provided the REST endpoint publishing capabilities. EMS is being deprecated, and the key things that we're doing with RAD Server is it includes all of the EMS technologies. It's the latest version for Berlin, and it has all of everything that EMS had. But we're also adding in our proximity and location services that are based on Beacon Fence. So you have a full license to that to use Beacon Fence in your solution. We're also adding in ThinkConnect technology, which is a framework for connecting to smart devices, and the edgeware, which is very important for these larger solutions where you need to connect in these smart devices into your services-based backend. And basically, you can think of ThinkPoint as like access points for smart devices into your solution. All of that is included, and the pricing it's a more straightforward, simple, and more affordable solution in RAD Server to deploy than was EMS when it was introduced.
So what we'll do now is we'll take a look at how to build up RAD Server packages, how to implement them, how to connect clients to them, how to use them on local server using either the developer edition or the deployment edition. And then we'll also show how you can use the ISAPI DLL version of EMS to deploy both locally inside your own firewall, as well as deploy to a cloud, in this case, Amazon Cloud. I just want to spend a quick moment taking a look at the data model for this department store RAD Server application. We've got a stores table with some different department store addresses and store numbers and store names in it, as well as a layout of the map of the store on the inside for the different departments. We've got a department table, which has the department name and department ID, for example, the toy department, the groceries department. We've got our customer table with customer information, and we have the EMS ID, which relates the customer in the department store database to the RAD Server user entries. We've got a products table, which has the different products that you'll see in the demonstrations. And then we've got Beacon Fence for departments and the fencing around those departments. And then we have an offer table that as you move into either a fence area or you're near a specific beacon, you'll get information and a special offer, for example, on your favorite breakfast cereal. And that's a quick look at the data model for the department store database that we're using in this RAD Server launch demonstration.
This is a quick overview of the architecture and vision for the retail demo we've put together for RAD Server. There's two parts to this. There's the RAD Server itself, which is the back end, and then we have the FireMonkey multi-device client application, which the customer will use on the front end. It'll run on either iOS or Android, and actually could run on Windows or OS X as well, but they're not quite as portable. So when the customer fires up the application, the first thing they're going to do is log on. And this is going to validate their credentials against the EMS database. Now, you could use an external validation system, whatever system you have in place that you want to validate your customers against, or you could just assign your customers a unique ID, and then the customer never has to mess with the username and password. It just validates them automatically when they connect. So there's lots of options available to you for how you want to validate your customers. Once the customer is validated, though, the application will request specials for the store that they're at from the RAD server. The RAD server will pull these details from a separate database that contains information about the retail store. while using the application has a beacon fence map embedded in it. In this case, we're using a hard-coded map, but that map could easily be downloaded when the user connects to include updates to reflect changes in the store, or if the user is visiting a store they've never visited before and that was perhaps created after the app was released. That can be downloaded dynamically. So now the user could use this as a map of the store to help them find things, to navigate the store, find the products they're looking for. But also what we're going to demonstrate here is that as the user enters different zones, so different departments in the store, we will send a notification from the client application to the RAD server, letting the server know what zone they've entered. And then that will give the server an opportunity to respond by sending down specials for the zone that they're in. And also, in some zones, we're going to have a light that's going to come on to alert the customer to a special offer. So as the customer enters the zone, when they get near this light, it's going to come on so that they can see what fantastic offer we have available for them. The lights can actually be turned on from the client application, and that's because we're hosting the server in the cloud, and it would require a VPN connection from the cloud down to the client application, or down to the local IoT devices in order to do that. Could have been possible, but our IT department didn't want to put that together this quick. Another option as well would have been to set up a local server that could then relay the information via another connection going outgoing. But again, for simplicity's sake, we're just going to activate it via the client application, which you may want to do in your situation as well. So lots of options for how this is going to work, but this is one example here. So the light's going to kick on, and then after either an elapsed timeout or when the customer leaves the sales zone, the light will turn off because we want to have it ready to turn on again when the next customer arrives. Another feature we added is for the customer to have the ability to scan a barcode or to search for products by SKU or text. And that will give them the ability to look up product information and price information as they're shopping. This can also actually be connected to the beacon fence system to help them navigate to the location in the store where the product is they're looking for, if they're searching by text. But if they are searching by product and they find the product they're looking for, they could potentially also buy that product right through the application. Lots of options here to see what they're doing, to include special offers for customers, if they have special discounts, etc.
Marco worked on some of the endpoints in the RAD server that's part of this department store application. So Marco, why don't you talk about what you built, and then we can take a look at it in action.
Yeah, what I've done here is just create a skeleton application that lets do a couple of different queries against the database data, and convert that the information that's filtered in the query into a JSON format. In this case, it's a specific JSON format for that FARDAC uses internally. So the point would be making it very easy to return a JSON structure that later will be easy to re-import into a FARDAC map table. And at that point, you'll be able to do local queries or processing or bind it to the user interface as needed on the client side. So the components here are just a FARDAC connection that's hooked to the Interbase database. And then there are two queries that basically are relatively simple SQL queries. We can open one of the two to see the actual code, but the code is actually fairly trivial.
And if we look at the code of the endpoints, I guess here you've got your resource is called item. Is that right?
Yes, I have two resources. One is for returning the entire data structure, a list of items, a list of elements. That's what you generally put attached to a GET endpoint. And then the second endpoint actually returns an individual item. So that endpoint has a further parameter, and it's triggered when the URL is item/ and then some ID that is passed to the code, and then the code can use as to replace a parameter in the query itself. Basically, for each individual item in the database table, you are mapping to one specific URL from the client. So the client calling the URL, passing the item ID, and that gets returned. And then the code does a very simple streaming of the content of the query into JSON format and returns it.
Okay, so we'll run without debugging, and that will start up the RAD server development server. Here it is, reg resource item, right? It has two endpoints, get and get item.
Yes, and then the task that we can do from that point is to open the browser. By default, it opens version check, but using /item as URL parameter, you'll end up seeing in the browser the JSON structure that's returned by that server-side code. And that same data structure is consumed by the client application. And basically what it does is rebuilds the, as I was mentioning, a FireDuck mem table. Then it's ready for you to use within the client any way you like, tying to a UI, doing processing, doing local storage. Once you have the data in that format, it's very simple to process on the client side.
Okay, and then you mentioned to me that you built a little test client as well.
The client is done kind of on purpose with very, very little code, but just using all of the components tied together. And again, of course, in the real world scenarios, you might want to add extra code and extra information to customize. It's certainly very nice, the ability using RAD Server and the EMS endpoint API's capability to be able to really simplify the development of the code. We had to write like a few lines on the server. There are even ways to reduce that, and we can write a few lines on the client, but the code needed is really minimal. And there are ways on EMS client to hook directly with FireDuck data. So that makes the development of the client side also very straightforward and very simple.
So if I run this and I just say, for example, get all, there's the grid of the products, for example. And then I can just put in a SKU code in the edit box and hit get button by SKU ID, and then I get the specific product in the product list there as well. Marco, over here on the client side, it's not much special to say about this, right? You just take the edit box of the get by ID.
Yeah, you pass it as a resource suffix that basically means the following element of the URL, so item / and that element that gets properly encoded, and then you execute the REST call. The information you get back on the client, if you look at the first button one click, that in that case I'm using a FireDuck client, a specific FireDuck EMS client, so it's completely hooked automatically. There's no extra code. In the second case, I'm using a regular REST request and REST response. So the REST response, I need to grab the content, which is a stream, and load that stream manually, with one line, into the FDMEM table. So in the first case, you can connect all of the components and have the same behavior automatic, or you can just write that single line of code, which is the reverse of what we have written on the server. The server was take this query, save it to a stream, and here is load the stream into a mem table. So it's exactly symmetric code.
All right, I'm here with Al Mannarino, one of our great field evangelists out of the New York area. Al, welcome to the webinar.
Thank you, David. Happy to be here.
And Al worked on part of the EMS backend, the part of EMS that is going to get the sales product items when the customer gets near an area of the store. I just want to spend a few minutes with you, Al, talking about how you implemented your part of the EMS server. So why don't you tell everybody what we're looking at here?
So thank you, David. So one of the key items with RAD Server is being able to have REST endpoint publishing for your APIs. So RAD Server is an application server for your backend, for your Delphi or your C++ building code. So you put your Delphi or C++ code into RAD Server, and it's going to create manageable REST endpoints. So what we're looking at here is we created a new EMS package that we're calling Get Sales Zone. And on here, you have a data module, and on the data module, we dropped a FireDuck connection component. And if you look at the FireDuck connection component, here's where we can connect to our backend data source. So in this case, we're connecting to an intrabase database, and there's the name of the file. And we can click on the test button to make sure we can test and connect to our intrabase database. So connection is fine. And on this data module is now where we can store some queries that we want to run against the database. So the first query we have here will go against our products table and bring back SKUs that are like 231. So there's the 3 SKUs that come back from this, or 3 products that come back from this SKU. And the second query would be daily specials. So when we run this query, it will return back the daily specials based on the store we are in. So now what we want to do now is we want to create endpoints that will run these queries and return the data back. So here we created a resource name called trigger, and we have an endpoint called get sales zone. So as David mentioned earlier, this endpoint is going to be used when the client, for example a mobile app, enters a beacon fenced sales area or zone. And then the client app will call this get sales zone API, and the client will pass the zone location of the retail store. For example, maybe they are in the cereal zone area of the retail store. And then we want to return back to the client all of the sales items from the sales area zone. And as you look through how we implemented this API, for this API we're making use of the tJSON text writer class that represents a writer to serialize the JSON data. And as you see here, if we walk through it, we're going to call that FireDAC query that we just saw earlier, that enter sales zone serial. We're going to call the FireDAC query enter sales zone serial that we sort of defined on this module. And then the JSON writer reference and pointing it to this JSON body, JSON writer. And that's going to put the results into a JSON object. So we run through the query and we return the rows, and it gets all returned back as a nice JSON object. And then we take that JSON object and we pass it to the colon client.
So now we've got our EMS package file. How do we connect that up to our EMS server?
Great question. So when you first create your EMS server, there's an EMS server.ini file that gets created, and there's a section in there that allows you to load these individual packages into the EMS server. So here's the get sales zone BIPL package DLL file that we created, and here's how you load it. So then other folks can create their own REST APIs and create their own packages, and you'll add them to this list. And then as EMS starts, all of these packages with all of these REST API endpoints will get loaded inside of EMS server.
Let's go here and start the EMS dev server we're using for development, right, Al? And then we have a production server as well?
That's correct. So EMS, as you see here, is either a Windows 32-bit or a Windows 64-bit application, and you start it up from command line. The EMS development server shows up, and as you look at the logging output, you see it creates this EMS server.configuration file, the INI file that we're looking at right behind it. We see that we're running a licensed version with 5 users max that we can use and test with. And then we see our endpoint got created. We have a resource called trigger and an endpoint called get the sales zone. So now we can now test running this endpoint right from a browser. So if we open up a browser and we pass it our resource name of trigger, and how we implement it or how we architect this application is the mobile client, as it's walking through the retail store, as it enters a beacon fence zone, if it's in the whatever zone it's in, we want to pass a string value for the zone it's in. So if it's in the toy department, we want to pass a string toy. If it's in the cereal department, we'll pass a string cereal. So for example, if we were in the cereal department, we want to pass that string cereal back to the EMS server, and that kicks off running that query that returns the cereals that are on sale for that zone. and here's the 3 serials that get returned from our database, and this information gets passed back to the client to look at and decide if they want to participate in any of these sales.
I'm going to be looking through at the new features within the RAD server to create auto-generated documentation for the APIs that you're sharing through your REST server. One of the key elements here is Swagger. Now, Swagger, or Swagger.io, if you want to go and visit the website there, basically is a tool that you can use to read YAML. YAML is kind of a subset of JSON. It's kind of a description language that goes beyond kind of what JSON offers. It documents your API. And using YAML, you're able to import the YAML documentation, and it's quite human readable, into Swagger. And then using Swagger UI or the Swagger editor, you can then see what the documentation looks like. That documentation can then be used through Swagger to generate SDKs for client libraries for a whole host of different programming languages, including JavaScript, Scala, and PHP. A whole host of different client-side classes can be generated from that YAML documentation through Swagger. So if you want to play around with Swagger, just go to swagger.io. You'll find the links there, but the key place to get to is really GitHub. On the GitHub repository for Swagger-API, /Swagger-UI. And then it took me a moment to work out where I needed to go really, but the key thing is if you go to the download zip, and once you've downloaded that, you don't need to do the building or anything else like that. You can just use what's in the redist folder and the redistribution folder to be able to run a local copy of Swagger UI, and you need to run it locally on your machine, so it's then within the domain to be able to connect to your REST server to then be able to get the full two-way interaction with it, which we're going to have a look at. So let's have a look at the existing EMS server structure. So you have your EMS server, and you then have an EMS client, and that client calls through REST calls to the EMS server, and you can have obviously multiple clients, they're calling to EMS server. Now, one of those calls that can be made is obviously for the documentation now. And to do that, you call API and then either API doc.json or API doc.yaml. And let's go and have a look at that running. So under the sample projects, and they're here for both C++ and Object Pascal, under database, under EMS, you'll find API doc attributes, sample, and if we go ahead and open up the package here, we can see this is just connecting to employee database table and fetching some data back, which it's then pushing out through a get call. The implementation for that in here is now documented by a few additional attributes that have been added on. So if we just scroll down here, we can see all of them. The first one is the endpoint request summary, saying this is under category of sample tag, and then with the title, description, etc. being passed in. There's also the endpoint request parameter. This one here is called skip, and that allows us to define a query. Here we can see if it's a part of the path, if it's a query, if it's a header, a body, or part of the form data. So here this is forming part of the query, which becomes a kind of question mark on the URL. And then kind of the additional properties define if it's a number, if it's an int32, for example. And there's also the response details. So here we're saying this is response 200, which is OK. And this is returning back an object, and that object is defined as definitions employee table. If we go and have a look at the top here, rather than defining the employee table on every single one of the methods, we can go to the endpoint object YAML definitions. And if we just click the constant that's here. So here we can see the constant that's been defined to tell out the structure of what's being passed back. Now, quite honestly, the quickest way to do this is just to run it once and then execute it, see the data that comes back, and then just take the values out of that. That's a quick way that I've done that in the past. But you can then build up here exactly what it is, the different classes and how they're defined and what they reference. So here, this table object actually references the item object. You can actually work with some of this straight out of the example. So what that gives us as we go ahead and run this server, if we open the browser now, And we can see that we're running version 2.1. Let's just go /API. We can see we have endpoints for API doc.yaml. And if we just do API doc.yaml, here we can now see the YAML documentation, which is pretty readable, defining what's in there. Let's just copy that, and I'm going to go ahead and open up my Swagger UI that I've downloaded. And I'm just going to go, for some reason I just need to disable it and enable it when I open up the page for the first time. I've got a cross-origin resource sharing plugin for Chrome here that allows me to then explore the documentation. So here's my EMS API documentation that's been imported from that YAML document. And here we can see the sample tag and the get. And here we can see an example which is defined from the constant that we had a look at earlier. We can see the skip that's defined. If we hit try it out, we can see the response come back and the data. And if we put kind of skip 5 and hit try it out, we can see now that that's appended as a parameter on the end because it's a query parameter. So working really, really well. And it's got the type defined here as well. So that's pretty cool. You know, the whole documentation is explorable here. We can go and explore the groups that are defined as part of EMS server. And we can see all the attributes and everything limited in there as well. So really, really, really careful. Also easy to use documentation through Swagger.
Let's discuss the deployment of our RAD server service application. We could use our own facilities, our own infrastructure, but it is more practical to use one of the infrastructure providers. One of the leading providers is Amazon Web Services that provides Elastic Compute service where you can run your virtual machines and deploy arbitrary software. So in a production scenario where we could have a number or big number of users, we would deploy our solution into a number of virtual machines. So we could provision application server where we can install RAD server bits and configure it in an auto scaling group where the number of virtual servers running would be dependent on the load coming from end users, and the actual data will be stored in a replicated data layer. For a simplicity, in this demo we are going to deploy our solution just in a single EC2 Windows instance. So if you click on a EC2 icon in the Amazon Web Services web console, you can select in which region you want to deploy your servers. In my case, I'm going for US West, North California, and in Instances tab I can see all my instances that I have defined. So you can see that right now I'm running one RAD server instance. Its state is running, and I have generated an Elastic IP address that is associated with my machine. So creating an instance in Amazon EC2 is very straightforward. You start from launch instance, and then there are 7 steps you need to follow in order to provision your virtual machine. First, you need to select Amazon machine image, so the starting point of your installation. In my case, I have selected Microsoft Windows Server 2012 release to base image 64-bit, and then after you select your image, you can specify additional information, so the size of your Amazon machine image, so basically a number of virtual processors and the size of virtual memory. You can specify a virtual private cloud that you want to deploy your machine into. You can also add some storage, so by default you have a 30 gigabytes of storage, but you can also add additional volumes. You can add arbitrary tag that will be useful for you to identify your virtual machines. And you also need to specify the security group. So here you can specify which protocols and on which ports can communicate with your machine. So when you're done, then you can review your machine and run it. It will typically take a good number of minutes, so maybe half an hour, for this machine to be provisioned and up and running. So these steps has already been done. So now I can log into the machine and do my configuration. So I have already connected to my remote machine using a remote processor, remote desktop connection. So on the server, you need to. There are two ways of deploying your server. So you can deploy it for development, for testing. So that is a standalone server that you can deploy to, or you can deploy to production, and in this case you would deploy your server as a internet information server application. So in the DocWiki on Embarcadero, you can see the list of files that you need to copy from your RAD Studio installation into your server application. So these are those files, and once you have these files copied, then you need to copy the files that are making up your application. So it's very important to realize that our application, our EMS server module is separate from the EMS binaries. So we are creating our EMS server as a EMS package, which is a BPL file. You can see inside my RAD Studio, when I create a new package, it is compiled as a BPL file. So BPL file cannot be run on its own. It needs to be run in a host. If we go into the project options, we can see that when we start this project, in fact we are starting the EMS dev server.exe, and then this is our host application, and it will load our BPL file. So on the remote machine we do not have RAD Studio installed, so then we need to copy the BPL files in a remote location. So in our case, in the case of our demo, there are two BPL files that I want to deploy. So I have copied these two BPL files into a specific location in my server. I have also copied the interbase database file that is used to store application data. And now I need to tell my server that these BPL files exist. So by default, in a users public documents embarcadero./ems, there is an EMS server ini file that you need to edit in order to specify information about which BPLs to load on EMS server startup. So if we scroll down in this list, we can see that I have added just 2 lines in a server packages section. So this tells our server to load our packages. So if I now restart the EMS server, and the EMS server I have created a shortcut for it. So now if I just start a standalone server, you can see in the log that these two BPL files, you can see there is a BPL file EMS retail service, and there is a second BPL file get sale BPL loaded. So these two files are loaded, and our EMS server is waiting for incoming connection. So we can actually try out if this server is visible from outside of this remote machine. I can just go into my browser and just use one of the endpoints that are built in, so you can see that I can see my EMS service running and waiting for incoming connections.
Hey, David, I here again. And as Michael mentioned at the beginning about the great thing about building RAD server-based solutions is that you can create your package files and install them into RAD Server. And they're just accessible by Delphi, by C++ Builder, and by any other language as long as it can do REST and JSON-based calls. I'm going to take that get sales zone package file, and I'm going to use a Java client application to talk to one of the endpoints. So here I've got my data module. It's got a Fire DAC connection, and we've got a query of the serials that we want, and then we've got the other endpoint for doing a query for daily specials. If we look at the code behind, we've got our resource called trigger, and we've got some endpoints, in particular a get sales zone endpoint, where we can pass it parameters and then get what the client requests. So if we go and look at the implementation of get sales zone, we can see that the parameterized query, which is going to be querying serial or whatever the client application asks for, and then it's going to run the query, and then it's going to use the JSON writer. Once it gets that query and activates it, it's going to go through the record count, make sure it's greater than 0, and then it's going to write out the JSON for product ID, for the product name, the barcode, the SKU code, the price, the sale price, and so on. And then when it's done, we're going to finish writing the JSON array, and then we're going to return it back to the client application. We'll start up RAD Server and see that we've got the registration of different endpoints, the users, the groups, installations, the push notification, some edge modules for doing IoT that's part of our solution, and we've got the trigger resource endpoints with the get sales zone BPL, and then we can use that to get an item or a group of items. And then I'm here in Eclipse, the Mars release, the latest release. This is the 64-bit version, and I've got a Java sample application here. Very simple, and what it's going to do is it's going to make an HTTP request to the endpoint trigger, and we're going to pass it the item, in this case serial, and then we're going to do a GET request. If it can connect to the RAD server, then everything is good. If not, we'll put out the HTTP error code. Otherwise, we're going to read what comes back from the connection and the GET request, and then we're going to output it to the console window, which is down here. So we'll go in and just say run as a Java application. And I clicked it a couple times. And down here, we see that for item equals serial, we get the JSON for all of the serials that we have in the database, the post honey bunches of oats, the barcode, the SKU code, the regular price, and so on. So they're a very simple example of using a Java client, calling into our RAD server, calling one of the endpoints, having the query happen going from FireDAC in the RAD server package to our Interbase database, where we have the tables that we talked about earlier, customers, in this case, the products. And since I asked for the serial items, then I get the result coming back for those. So you can use any programming language that can make a REST call, can do a GET request, and accept back JSON coming back. And then you'd write the rest of your code on your Java client, your Python client, or whatever to do the user interface or the displaying of the products that you're looking for. That's how simple it is to use Java client to talk to a RAD server endpoint and get the data back.
So I'm going to show you how to use one particular client framework called Angularjs. It's a client application in that it builds a client application that's in HTML and JavaScript using kind of a model view model framework. It's designed by Google. There's lots of documentation here on the Angularjs website, as well as other websites. So I'm not going to go through and explain how to use Angularjs, but it's a standard Angularjs REST client application because we're building the RAD server is a standard JSON REST server. You don't have to know anything special to consume it if you know Angularjs. So I have an example application here. This was put together by Jim Tierney, one of our fantastic architects in R&D. And we're going to go through this. He has documentation here, although there's one step that's missing, which I'll explain to you, and we'll build our client application. Prerequisites, note that you have to have Git installed. If you go to GitHub's website, actually, if you just go here and say clone or download, it'll give you the option to install Git for Windows, GitHub for Windows, and then you'll have Git installed. You just say, hey, I want to include the client application or the command line applications, command line utilities, I think is what it's called. You'll see it in there in the installation. Also, you need to install Node.js. So this is a JavaScript runtime, and this is used to build the AngularJS client. So the way AngularJS works is you construct your AngularJS source code, and then you build it, and that in turn installs or builds the compiled version of the JavaScript. So it's not compiled JavaScript into machine code like we normally think compiled, but it goes through and it builds up all the pieces it needs to have and constructs these JavaScript files that are then used in the client application. Okay, so you need to download and install, like I said, Git and Node.js, and the rest of it we're going to do via command line. So the first thing we're going to do, though, is we're going to install the resource. So this resource here is a DPK, dproj. This is a Delphi project that is a resource. So this is just like you've ever built a EMS module before or RAD server module before. This is the same thing. So we're going to go ahead and install that in IIS as an SAPI module with EMS server. Okay. Now there's great documentation in the doc wiki on how to do this. I'm going to walk through some of the big steps for you and mention a couple things that caught me along the way, but realistically, this has got great documentation. For example, I missed this step right here to make sure you install SAPI extensions. Obviously, you need a SAPI extensions, but I didn't read that step. So the way you're going to get started by installing this is on Windows 10. You're going to go Windows key X, which brings up this super awesome menu here. Go to Programs and Features, turn Windows features on or off, and you're going to check Internet Information Services. Now, by default, it gives you this box, which means it's partially checked, which means it's not installing everything. You could just say, hey, give me everything and click on it again. Or if you come in here to World Wide Web Services, Application Development Features, you want to find SAPI extensions and filters and check those because those are not checked by default. I put CGI as well. I don't know why, but it's there now and I'm not going to mess with it. So once you select those, you hit OK. It's going to go through and install them. Doesn't even require a reboot, which is great. And then you're done. You have IIS installed. You can test that by going to localhost, and you'll see the beautiful Internet Information Services splash screen here where it says welcome in all these different languages. And now you feel welcome. So we've installed IIS. So now we need to install this module here. I'm not going to actually go through the process of building it. Oops, I went too far back. But it tells you right here that you need to build it. Let's see. Somewhere. Well, you got to build it. It's a Delphi project. Right there. EMS build. Build resource package in 64-bit target. So once you've done that, you're going to, it's down here, it says IIS configuration, create virtual directory, copy the file over, configure EMS server INI file, and so on and so forth. Now, because we're installing it into an SAPI module, you have to have the full EMS license. So you're going to install a full EMS license, and then you have to run the EMS installation again. So let's show you how to do that here. You're going to go to command line, and you're going to run EMS dev server -setup. Now, if you haven't already installed this the first time, then as soon as you run it, it's going to run and install it. But if you've installed it, you're going to reinstall it again so that you get that set up correctly. You're going to give it a server instance. Now, I just used the GDS DB, which is the default interbase instance. Most people create their own server instance called EMS, and that's what the doc wiki is going to tell you to do. This worked for me. Use whatever makes most sense for you. And then sample users and sample user groups is going to give you that test user that you use for everything, or at least I use for everything in development purposes. So make sure you include that for simplicity's sake. And if you want to change the console user or console path, you're going to do that here. This is the location, the default locations. I just left everything default on mine. You may want to change that, and you're going to hit finish. Now, if you've installed it previously, it's going to say, hey, that already exists. Do you want to override it? And if you hit yes, it's going to just take a couple seconds, give you a little splash screen that tells you what it installed, where, what those default users and passwords are. I'm not going to do this because I've got it working. Pretty sure if I were to do this, it would work fine, but I want to make sure I can show this to you right. And sometimes reinstalling over the top, I guess, I'm just nervous. So we'll just leave it at that. But if I were to hit yes, I'm pretty sure that it would work, but I don't want to have to mess with it again. So there we go. I'm not going to run the development server because this is going to be on port 8080. But remember, we're installed on IIS at this point. So now we've got the EMS installed in our IIS. Oh, wait, actually, I forgot one more step. I got to come over here to the Internet Information Server Manager screen. And this is explained in both Glowacki and on the right here. We have to come in here to our default website, and we're going to add the RAD Server virtual directory. So you just right-click on default website and say add virtual directory, and that puts that there. And also you have to come in here and turn on IIS or SAPIs. Let's see, open feature. Where is it on here? Handler mappings. So there we go, right here. Enabled SAPI DLLs. So SAPI DLLs are enabled so that they can be executed. So I was at the wrong spot. I have to be on my website that I've currently installed. Okay, so that enables the SAPI DLL so the SAPI DLLs can't execute. Otherwise, it tries to download them. So the way you can test that to see if that's enabled correctly is if you come here to localhost. So RAD is our virtual directory /EMS server.dll, because I've copied those files in there. I guess I didn't show you that. EMS server. So here is our EMS server.dll /version. So this is going to actually execute the EMS server and show us the version information. So this just tells us it's running correctly. So in here, make sure you have the EMS server INI file, which you're going to want to make sure is pointing to the Interbase database, which that during the installation process, it popped up and told us this is where it was installing the Interbase database. And in here for our demo purposes, we're using the right here, notes resource package, which is included in GitHub. That's this guy here. And the resource is the notes resource package right here. See notes resource package. So you're going to build that and put it in this folder here, notes resource package BPL. So C inetpub rad notes resource package BPL. C inetpub rad note resource package BPL is the notes resource. I think that's the only two changes you have to make in here to get things working. It is all described in the documentation here as well and on the Glowacki. So now let's go ahead and go through the process of actually building the Angularjs part. So like I said, you have to install the Node.js because that gives you the Node package manager and the engine that runs all the compilations, because all the code's written in JavaScript and it compiles it on Node.js. Now, when we actually run the client itself, it's all running in the client side in the user's browser. It's not running on your server. So you don't have to install Node.js on your server. You're just using Node.js and these other utilities I want to mention here to build the Node or build the Angularjs client application. So we need to install Bower, which you install with Node Package Manager npm. So once you've installed Node Package Manager and you restart your command window, then you'll have npm available to you, Node Package Manager. So to install Bower, we're going to do this right here, install -g is global. Bower is the name of the package. So this is going to go out, download the Bower package, and install it and all its dependencies. This is going to take a little bit, so I'm going to actually just speed up the video at this point so you can see the installation go through. It does take a while. It's extracting right now. So there we go. Bower's installed. The next thing we have to install is Gulp. If you read the page here, it mentions that it uses Gulp, but it doesn't say to install Gulp, but that's okay. It's easy enough to install. We're just going to go over here and we're going to say node package manager install -- global, which is just the long form of global, and then Gulp CLI. So let's go ahead and do that. Again, it's going to take a little while, so I'm just going to let it do its thing, and I'll speed the video up so you don't have to watch the whole tedious process. Oh, wow, that was much quicker. Never mind. I'm not going to speed that up. I might slow it down because it went by too fast. Okay, so now we've got Bower and Gulp installed. So now we have to come back here and we're going to download the project. So to do that, I'm going to actually go onto my desktop because that's where I like putting temporary projects I'm working on. And we're just going to use Git to put that on the desktop. And so this is going to clone it. It's going to go out and grab the project and download it locally. So now I'm going to go into EMS Notes in G, and we have our project. So now we're going to build this with Angular. Okay. If you go into, actually we'll go into the client folder. There is a source folder here. And this is what actually defines the Angular app. And so what we're going to do is we're going to run the build, and it's going to go out and build from the app. It's going to build our distribution files, which we can then install into IIS to be downloaded into the client application. What we need to do is we're in the client folder. So now we're going to use the node package manager to install our client application. Okay. Or npm install. And so that's going to grab the information from here to install it. Now this part I know takes a while, so I will be speeding this part up. Let's make this bigger. I'll put the instructions with there. We've finished the installation. So now we're going to install, or use Bower to install it. So Bower is adds in some of the other dependencies that are needed for the application. So we're just going to say Bower. And there we go. Bower's got everything it's going to do. So now we're going to do the build process. And so that we use Gulp. Let's remember I said we installed Gulp earlier. So we just say Gulp build. And again, it's going to build what's in the current directory because we're not telling it something else to build. You'll get these errors here. They're not important errors because they're referencing things that aren't referenced essentially there. So it's basically just a warning level turned up higher. And there we go. It's finished with the build process. And so now we can actually test this. And we do this by saying Gulp test. And you're going to notice we get the errors again, but that's okay because here's where it's actually running the tests, and all 18 tests passed successfully. So there we go. We've gone through and built the client applications. We can take a look at this actually. Let's go ahead and minimize my window here. And if we go to, let's open a new window, desktop, and EMS Notes. Client. Now we have a new folder here called dist, which is the distribution files. And so these are the files we're going to copy. And actually, if I double click on this here, well, it opens it in Internet Explorer, but this is the Angular.js application. Okay. For right now, though, it won't work because it's not actually running on a server and it can't connect to EMS. But so here, if I click login and we'll say test pass, and I click login. And no, we don't want to say the password. And it's going to just do nothing because it can't actually connect to EMS. But that's okay. So we can take this, copy this to the client folder here. So we see it's I already installed earlier. And now we just go in our browser to localhost. I guess I clicked back there. RAD/client. So that puts us in the client folder, which is going to execute this index.html. So we see this looks the same as it did there. And now we can log in. So I'm going to use test and test pass to log in. and we've logged into the server. Go ahead and get rid of some of these other windows back here. We're going to make a new note. Here it is hello world. And text is there you go. RAD server works with Angularjs 2. We'll make a second note here. 2. And we'll make a third note. 3. There we go. And so I can log out and log back in again. Test, pass. And we see there are all my notes again. Now, this is actually persisting against EMS. So if I go in here and we'll go to RAD Studio, and I've created just a simple little application here. We have our provider pointing to localhost 80. RAD EMS server is the base path. Here's our endpoint, and I executed this previously, but let's clear this out for now. Clear response data. Yes. And here's our authentication using default authentication, and I've hard-coded test, pass, and test. And here's our backend endpoint, which is using that auth and that provider. And we just tell it the resource we want is notes. And then we're taking that and putting it into a REST response here, which we then use the REST response dataset adapter to put it into the FDMEM table. So let's go ahead and log back in again and execute the endpoint. And we see now we've got all 3 of those notes. This is the actual data that's in there now. And so let's go back into here, and I'm going to delete note 3. And here, actually, I'll just run it. But what I've done is I've bound the endpoints has a REST response.json text is what I've put into the memo. And then the FDMEM table I've bound to this list view. And I'm just taking the item text and putting that in the text. And then the header text is the title. Okay, so the title is going to be the title of the note, and then here's the contents of the note. So let's run this. Oh, there's 3 lines of code, 2 lines of code, 2 lines of code. And here, backend auth, login, and backend endpoint execute. So we'll just run this one real quick. And I forgot, when I execute the login, it changes the authentication to session. I'm not sure why that happened. Something I must have set wrong. But just change it back to default and run it. Probably because it gets a session token at design time. Anyway, so there we go. Execute it, and we see there is the code, because remember I deleted note 3, which was there after that. So I can actually go back into here, and I'll delete note 2. Yes, delete note 2. And go back into our client application. And I don't have a refresh button, but that works. And we see that note 2 is deleted. So there we go. Really cool. We just built a AngularJS client to talk to an EMS service, in this case, just our note service here, and it's able to persist the data into the backend database, which we can then access from our Delphi application or C++ builder application. Just those 2 lines of code you can change and access that same data, that same backend, because RAD server uses REST and JSON.
Michael's back with me. And Michael, we just wanted to talk about pricing, but I think more important, how developers and businesses who are thinking about using RAD server, how do they package this up and deploy it? What are the different common business scenarios, and what does it mean as it relates to features and pricing?
Sure. So there's really 3 different types of kind of core scenarios. There's the single site scenario, multi-site, and then per device, and they're really designed for different types of customers and use cases. And we understand that everybody's business is different, and everybody's applications and solutions are different, and they're priced differently. And so we want to try to achieve simplicity. To make this easy and affordable to consume and deploy. But we also want to provide flexibility so that it can work with a wide variety of different business types. We have really 2 key different customer types. Customers that are building internal solutions, sometimes we call them enterprise customers or enterprise solutions. And these are development groups that are building a solution for internal consumption. So it's something that's going to be deployed inside the same company that's developing the solution, and it's going to be consumed by typically internal users, but it could be external users on a web, through a web page or through through remote clients. But basically, it's not for resale. It's something for internal consumption and internal use. And then we have the other set of our customers who are ISVs or independent software vendors who are building solutions that will be redeployed across other organizations. So they're building solutions either for resale or part of some type of hardware-software combination, something that's going to be redeployed or resold to many different organizations. And there's really two scenarios there, and we'll talk about each, talk about those inside the ISVs. But to start with, for enterprise customers or for internal use, we have our single site license, which is it's 5K per server, and we've made this unlimited users. If you remember in EMS, it was a charge per user, and these could get quite expensive very quickly. As in internal use, we have customers that have tens of thousands of internal users, and so we wanted to make this something that every Delphi developer, every company that's using building a Delphi solution could use. And so we set the price at 5K for unlimited users, and that's for a single server. And what we mean by a single server is a single back-end user database, essentially. You can have, we do allow redundant endpoints. So you can have a single back-end which has your user database and your authentication rules and access control rules and things like that. And that's kind of the controller on the back end. And then your endpoints are individual modules, and those can be redundant. You can have multiple. So if you have one endpoint called, let's just say it's called currency conversion, you could set up 5 of those on for scale or for redundancy and failover, and use IIS's web infrastructure to manage that. And that's all included under the single site license. So failover and scale are all built in from that perspective. Now, if you have different departments in your organization, or it's a very large organization, and they're going to have different solutions running on different servers and with different backends. So if we move to the next slide here, this would be using the single site solution, but using multiple servers. So basically, this would be, you'd have a separate license for each backend, and each backend would have a different user database and different authentication rules, etc. And again, this is really geared more towards internal use enterprise organizations. The next scenario is the per device licensing. We have a set of customers who are typically ISVs building solutions that have very low user counts. As I said earlier, everybody's different. Everybody has a different business model and different types of solutions. And there is a segment of customers that have very small user counts. So they're deploying a solution. We have one that has a solution for clinics that they have 3 or 4 clients. And so they have many different locations that they're deploying to. So they maybe one in every city, and every city in Europe will have a clinic, but they only have 3 or 4 clients accessing each of those locations. And so for that, we've developed the per device licensing model. That's basically for many locations but low user counts. And that's just priced at $99 a client. That helps facilitate that particular type of a customer model. Measured basically by the hardware device. So an iPhone or an iPad or a desktop PC or Mac. And then per device licensing for multi-site and multi-server. This is basically the same model we just described, really. This is just taking that and spanning it across multiple sites. So in this case, you're just expanding it across multiple end customers. What's measured and what's licensed are the end client devices. If you are building, building a solution that's going to go across one or many customer locations, but it's going to only have a few clients per customer location, then you want the per device licensing. That'll give you the most affordable solution and the most scale. Clearly, if you started this in this model and you wanted to and you evolved your solution up to where you had thousands of end clients, then you might want to switch your licensing model over, and we'd be happy to work with any of our customers on tuning the solution to the right business model if their business evolves or changes over time. And then the last one is our multi-site license with unlimited users. And this is for our larger ISVs who are basically deploying high user count solutions across many different sites. For this, this would be very similar to the single site license with unlimited users, but we'll tailor this solution for your particular business. And just very similar to Interbase, when the deployments get high, our sales team will work with you on a pricing model that'll fit your business model and work for both Embarcadero and your business.
The pricing is that per deployed application? Is that per year?
It's a license price, and there's a maintenance component, and that maintenance component is the renewable component. Let's just say on the single site unlimited users license, that's $5,000 for the license, and it's, I believe, 25% for the maintenance component, and that's the only part that's renewable. If you remember back to EMS, it was a subscription fee, so the EMS pricing was higher and it was annual. Now it's a single price up the license, and then there's a smaller annual maintenance fee.
As we add functionality to the RAD server underpinnings, you would get that RAD server functionality as part of maintenance.
Correct. Both new features, performance enhancements, and quality fixes. So bug fixes.
And we started RAD server. You need, what is it, RAD Studio or Delphi or C++ Builder Enterprise and above. 10.1 Berlin.
Correct. For the development side, you need it requires any enterprise. We call enterprise class SKU or edition, which would be enterprise or architect of Delphi, C Builder, or RAD Studio. In Berlin, all of the RAD server components for developers is included, and there's an eval license included. So you could get started today just with Berlin out of the box.
And that's for doing development, for doing debugging, testing, doing some test on a cloud server or whatever, again, to make sure that the solution that you're building, the service you're building, is working.
Correct.
And then either go online or contact us or our reselling partners for the actual final deployment.
Correct. Yeah.
Okay, well, thank you very much, Michael. And now we'll take your questions.
Jay has a question about a link for connecting a mobile application to RAD server and then getting data on local devices and storing it, querying it, analyzing it. So I'm going to give you a link, Jay, here to the DocWiki. Has a tutorial on implementing your first EMS client application, which EMS is the server used inside RAD server. Part of it, I don't want to say it's renamed, but it's kind of evolution. So we use those terms interchangeably, which may make it a little interesting for looking at documentation, but know that they work together.
And those links all in the blog post as well. The building an EMS package tutorial as well as the mobile tutorials. I think also in his sort of text, he talks about what about local storage, and we have many videos about using, for example, IB Lite, or using local storage files, or using an INI file or a text file, or SQLite and other things if you want to persist data mobile on the mobile device or desktop device for that matter, and then synchronize it back to via RAD server back to the backend database by calling apply updates, fire DAC handles caching, and we've got lots of tutorials about how to work in a connected, disconnected world of mobile and desktop talking through multi-tier, either through DataSnap or RAD server to the backend.
Yeah, so I'm going to give you a link here for the local SQL skill sprint that'll walk you through using local SQL against that FD mem table.
Yep.
there's tons and tons of stuff out there as far as, like David was saying, persisting it, doing the changes and stuff like that. But the local SQL stuff is really cool, so definitely check that out.
And DataSnap still is available if you want to build everything yourself using DataSnap multi-tier technology. You can do that. I think the difference in DataSnap, we give you all the pieces and parts in the framework. In RAD Server, everything is built for you. User management, other than populating your user information, push notifications, local storage, beacon fence, all of the things that you would see, analytics, all of that is pre-built for you, and you just get the benefit of all of that. Just create your packages, put them in, you get the analytics being captured, and all of that is turnkey. So that's the subtle difference. DataSnap's still there, and it can do REST JSON as well. So it's in a sense your choice. And wherever you see EMS in the DocWiki, think RAD Server. Right? RAD Server leverages, as Michael mentioned at the beginning, the EMS technology, the frameworks that we use under the covers, the JSON, and so on. And as you saw in Jim's presentation, you can run it locally in ISAPI DLL, and as you saw in Pawel's presentation, you can also create and deploy to Amazon, or for that matter, Azure or Rackspace or Docker or any other cloud-based system, as long as you have a Windows instance, so that we can run IIS. And then eventually, when we have the Linux compiler and Linux server support, you'll be able to deploy your applications to a Linux target, your server side to a Linux target as well. Okay. Some of the suggestions that have popped in, I will pass along to product management and to marketing and sales. I think Gerard, I'm sorry if I'm saying that wrong, he was asking, can he create multiple different clients that talk to RAD Server? Really, applications, yes, reservation, legislation, audit, and so on. Absolutely, and you saw some of that. You saw us building different endpoints, and you can put all of those endpoint packages into a RAD Server container. You saw that in the samples. And in the pricing, it's unlimited number of endpoints. You just keep adding, either add interfaces to an existing package, or add more packages. Better from a microservices standpoint would be to create packages based on functionality that hangs together. So you could have a RAD Server EMS package for reservation processing, for legislation processing, for auditing, for payments, for other kinds of things, and then have your client application, whether it's a desktop or mobile application, call the endpoints that it needs to do its work. So the answer absolutely is yes, and it's really for you to break up or package the different functionality in one or more BPLs. Marco did a few endpoints in his package, and Al did a few endpoints in his package that were based on different parts of the application, querying based on a type of or a department code, and Marco based on what was happening in the store, for example. So you can absolutely decide how to split up or combine your packages. There's no limit in RAD Server in the pricing based on number of endpoints or number of package files. That's unlimited. It's how you want to architect your application. Me, I favor putting like functionality in a common EMS package file, but you can put everything in one. So leave it to you to decide how you want to quote unquote package up the reusable functionality. And all of this code is a work in progress, and I put a comment in the blog post for this webinar. We're still working on feature work for this demo, but we used parts of it in the RAD Server launch a month ago, and we've added some more functionality today. So now is the time we'll package up all the demos and the data model and everything else into a zip file, and that link will be added to the blog post for this webinar. Again, the short URL is embt.co/RAD server deep dive. First letter of each of those parts, uppercase, uppercase R, uppercase S, uppercase D, uppercase D. And that is, again, in the chat window. And then bookmark the source code project on Code Central, because we'll be adding functionality. And I'll put a README file in the zip file for the source code that tells you some of the features we're still doing, because these applications are works in progress. There's a list of additional things that we'd like to hook in as well. And then Jim's going to put into the blog post for the webinar the link to the GitHub for the Angular sample that talks to a notes database. But we want to take Angular and have a client, for example, that would use maybe a back office, use a web interface, for example, to edit pricing of products. That would be a great sample that says, you could do that, of course, on a desktop or a mobile app in Delphi or C++ Builder, but what you may have a different part of the team that is that does Java development, or another team that does web-based development. So why not be able to use those same backends to get the data, but have different clients? So that's what we try to show, showing you Delphi, C++, Java, and JavaScript, Angular, JS clients. That's the beauty of having a pure solution in RAD Server backend that is REST and JSON based.
And there's a question here about using Electron as another client to consume it. If you can consume a REST service, which a lot of tools out there can, then it can be used to build a client application. It's very simple, very straightforward, very much a standard REST server. So should be very easy to build clients in whatever tool or framework you want to use. There's a question here about, can RAD server run on one web server, or can multiple RAD servers run on one web server, each talking to different databases? So the RAD server is going to be running on a let's see, I guess you could do that. You could have it at different virtual directories. So in my part, I showed you how to install RAD server, the EMS server, into a virtual directory. So it would be on one port 80, because the web server would be on port 80, but then you could have multiple virtual directories, each virtual directory with a different RAD server instance in it. Another option you could do is you could have one RAD server EMS instance, and then that instance could have multiple packages in it, and each package could be talking to a different database, because each package has the database connections within it. So you could do that, and I would guess in theory you could have one package that was talking to multiple databases as well. So really lots of ways to slice that up, and I guess you could then replicate that across multiple servers for redundancy's sake. So yeah, like I said, lots of ways to slice that up, just depending on what the best solution you want to have for your scenario. How would that affect licensing? I think it's per RAD server license, if I remember right. Correct. Yeah, so that would be a per. Well, it depends on which licensing you use, I guess, actually. So if you're using the server license, then that would be multiple servers, because each server is doing something different, if I understand correctly. If you're using the per device license, then if you still only have 3 devices, then that's fixed. So it really depends on, if you've only got a few clients that are going to be connecting, then go with that license and you can have 100 servers. But if you're going to have thousands of clients, then go with the server licensing.
Yes, so the license and the cost is based on the user database. So not the user database that we had, for example, the customer backend database, but the RAD server user database. So in a sense, it's per user database. So if you have lots of RAD servers all configured to use the same user database, where you buy either unlimited license or per device, that's the key. But again, if you're unsure, for a scenario you have, contact our sales office, our resellers. But I think Michael said it very clear, and I'll put some notes in the blog post again. It's the license that you pay for to get that user database. And you could have multiple RAD servers running on multiple machines. If their INI file is pointing to the same user database for managing users, then that's where the license comes in. And that's separate from talking to back-end databases that are part of your application, right?
Okay, that I didn't quite get that. That makes sense.
The way to think about it is how many user databases with user access control and permissions and device registration, all of that kinds of stuff. How many of those do you have? Either you have one or multiple, or you decide again per device, and then you don't care. You could have multiple user databases, multiple servers, and you're going to be restricted only by how many devices can connect. So you could start thinking about, well, gee, what if I created a server, for example, that was my connection? So there's all sorts of ways you could architect the system to do what you need. And the best thing, again, is contact our sales office. They'll connect you to technical sales engineers that we have in the field to talk about some of these kind of architectural and implementation deployment solutions or situations, and they can build up a quote for you. I wish I could have a spreadsheet where you just fill in the columns, and maybe somebody will write an app that does that. Okay, I think that was most of the questions. Again, the questions about what different solutions you might want to use, as Jim mentioned, as long as you have a solution or framework or package you want to use that can deal with JSON and REST-based calls, you could implement a client in Python, or as you Ruby, any other language that you might think about, C# and so on, and we'll work on some additional client demos that talk to RAD Server over time. This is our last webinar for this month of June, but we're doing the process now to come up with additional topic-based webinars for the coming months throughout the rest of this year. So if you have suggestions, you can send emails to any or all of us for topics you'd love to have us cover. In the Northern Hemisphere, it's also summertime, so we're aware that some people will be on vacations here and there, but if you miss, we're still going to move ahead with the webinar series, and you'll just catch the replay on the Embarcadero YouTube channel when it's available. Again, you'll get an email from GoToWebinar, which has all the links as reminders. I've been pretty good about getting the webinar replays up, both as a complete video as well as the individual parts within a couple days after the webinar. For the mobile one, I had it up on Friday, and all of those are available on the Embarcadero TechNet YouTube channel. So you'll get an email as a thank you with all the links that you need. And if there's anything else you need, send us emails. We love them. Okay, any last words, Jim, Marco, or Pawel?
I was just thinking, if there is a specific technology that you think is different that you'd like to see us use to build a client application, let us know. We can take a look at it and see. Like I said, if it has a tutorial available that says, hey, this is how you connect to a REST service, just use that and connect to notes, and wham, look at that, you've built a client application. But if there's something you'd really like to see in a future one, let us know, and maybe we can incorporate that, assuming we can figure out how to do it.
Okay, there were a few questions here and there about authentication. So out of the box, RAD Server does authentication against the user database. So when you add users, the wizard adds a standard user test and then test pass, and you can add other users using the console. And so it'll validate against the user database, which is the EMS database that is running a version of Interbase to Go. or interbase under the covers for keeping track of users' devices and so on. And then there's a hook if you want to do other forms of authentication. You can do attribute-based authentication. You can also get a hook to go out to whatever your authentication system is, whether it's LDAP or something else. So while we don't have a LDAP component you drop down, there's a way for you to make those calls to whatever your system is out there. And there are, other solutions and libraries that you can use, including Windows API calls for getting out to Active Directory, LDAP, and other kinds of things. Our demos included with 10.1 Berlin. There are demos for RAD Server EMS. Look under the samples, Object Pascal, look in database, and then EMS is the subdirectory. I'll put the links to the samples in the blog post. There's also C++ versions. The sample that Jim showed that had an Angular client and an EMS backend, that's our notes package, demo package. That notes example is shipped with the product, not the Angular.js. Jim's going to put a link to the GitHub for the Angular.js client side. I don't know if you've done that yet, Jim, but Jim will put that. Yeah, he'll put that link in the blog post for the webinar, and I'll zip up our other demos that aren't ones that ship with the product and put those put those in Code Central and put a link in the blog post as well. Again, the short URL is in the chat window to the blog post for this webinar.
If you take a look at the DocWiki, the tutorials really do a good job of walking you through building it. And I find personally doing a tutorial it's much more informative to me than looking at a sample application.
And I have the links to the tutorials for building packages, reusable packages, as well as building clients. So those links are in the blog post right now. Let's see. There was a question, it was partially related to licensing and then how you spin up multiple instances for load balancing and so on. And Michael covered all of that at the end. I'm not sure if it fits specifically, but one of the comments or question was, what if you are on Amazon and you're starting up the Amazon load balancer and spinning up multiple instances of these package files, these ISAPI DLLs, and if you saw the licensing, there's no charge for running packages, right? The charge is related to how many users, either unlimited users or specific number of devices for single site. So single site, on multiple servers, for example, that was covered as well. So all of that is provided for when you purchase your license keys for deployment. Now, if you're still not sure, contact our sales office, contact our reselling partners in the country, wherever you are, and they will connect you as well with a field evangelist that will understand what your specific requirement is for your deployment and guide you and build a quote for the number of licenses and the type of configuration that you need. So that's the best that I can say. Starting up multiple IIS instances of the package files still is only using a single application and a single user database, right? So, or you could go the other approach where you could have, say you only need to support 6 devices at a time or maximum. It doesn't matter how you scale up the back end if those 6 devices are beating on your RAD server implementation or deployment. So no matter how you ask the question, whether the instances of the package files or ISAPI DLLs are created on the spot when needed, go ahead. Create is, spin them up. You're still either going to go back to a number of users, either unlimited or a number of devices, limited by how you grow the number of devices connected to your system and how hard they're working. So For security, we do authentication, and you can decide by groups how users or client applications can access your endpoints. And we support HTTPS. And on top of that, if you deploy an IIS, then you get all the IIS security that you can set in the IIS management console. So go for it. You could even, if you want to decide to encrypt and decrypt your JSON on both sides of a connection, even when you have all the rest of this security, you can do that as well. The user database, again, we're getting back to the user database is the interbase database. That's the license you're getting. So if you have an unlimited number of users, then that database can be placed somewhere, and it's only used for authenticating users and registering devices. The rest of the operations in your endpoints is going to be calling some other database or some other service or some other cloud-based system or whatever your business logic is. Those are the things you'll want to spin up. And then on the database side, meaning the application database side, that's going to be based on the number of users you have for an Oracle database or a SQL Server database or a Postgres database or an Interbase database or whatever. So the user database is how you have the number of licenses. So if you have, as Michael mentioned, if you have two different user databases for two different sets of users, you need two licenses, either for X number of devices or unlimited users running on separate user databases. All right. So maybe that'll make it simpler. The license on the sites is the user database, not the business database. I don't know how to differentiate it other than say the RAD server user database is what you're getting licenses for. That's an interbase encrypted database that you can place on a server. And the INI file, as you saw in several examples, you can point to where that the RAD server user database is placed. Okay? And if that doesn't answer it, send us an email and or contact our sales office. So if you're worried about failover, if you're worried about configurations and so on and replicating databases and such, talk to our offices and they will help you configure the bid that you need to satisfy the requirements of the system that you're implementing. Okay, I guess I could say it simply that way as it relates to failover, single point of failure, and so on.
I would suspect, and again, talk to sales and they'll make sure you get it right, but there's probably is a way to make that work where it would be a single database, but it's replicated instead of being different data. There's a difference. One database that's replicated is not two databases. It's still one database.
Still one database, exactly. The multi-site is when, as Michael mentioned, you're going to have two completely different applications with two completely and or maybe overlapping sets of users that are going to be accessing different functionality as part of your solution. So, contact sales. I'm not sure about this one. Have pairs the same over multiple servers or have a queue system implemented connecting things like Redis? We don't do any queuing. That's what cloud systems and other load balancing type software do if it's related there. Jim, do you see that one at 12:31 p.m.? Capital REDIS.
I do see that one. So I'm not sure what point you wanted to connect to Redis or a queue system. There are components. If you want to deal with a queue system, you can totally do that. As far as having your packages implement that. But if you're wanting to use that for your user database, that I don't think that would work. But yeah, if you want to just have a package that, you know, maybe it's a REST service that someone connects to and says, hey, is anything in the queue? And, oh, it is. Okay, let's grab something out of the queue. You can do that. That's totally possible. There are components that do that. So yeah, the way you build the EMS packages is very flexible, and really anything you can find a library for Delphi or C++ Builder or an API that you can call, you can do that.
And as Jim mentioned, if he had created 2 virtual directories with 2 sets of the same or different EMS packages, each one of those would have an INI file, right, Jim? And inside of that INI file, it would point to wherever your RAD server user database is, or
Right.
R. Okay.
So here is
redis.io. Okay.
And here is a Delphi library for working with Redis.
Okay.
So all you got to do is use that library, build a module that talks to Redis, and you're off to the races, as they say.
Yep.
Works with Berlin and everything right there. Good to
Excellent.
go. By Daniel Titi, one of our fantastic MVPs.
Out of Italy. Bit time. Absolutely.
He's got a new book coming out too, Delphi Cookbook. Volume 2 is coming out in the near future. So if you don't have Volume 1, get that now, and then when Volume 2 comes out, get that one.
And Sriram, who's a he's the program manager, the head of development for Interbase, just made a note that you can use Interbase's incremental dump or journaling activity features to have a standby database server to recover from any disaster. So there's
true.
Yep.
Yeah, there's lots of options there. So you're covered both from a technical point of view and from a licensing point of view, if I understand what your question correctly.
And if not, send us emails and also contact sales. I mean, this is all good fodder for additional things to cover on RAD Server in the coming months. So we'll take a look at what more we need to do. Maybe we'll create a scenario, Jim, where we put, have failover load balancing. Pawel, I know, is working on a bunch of things as it relates to Amazon and Azure and configuring and setting up and balancing and security and failover. So we'll take a look at what he creates. He's working on a white paper as well as some videos. So to go even deeper.
Excellent. Yeah, he does good work.
Okay, everyone. Oh, go ahead, Jim.
Just saying, looking forward to that. So good, good to know.
Yeah, there's much more to come. We're going to cover RAD Server in all sorts of ways, including additional business domains and scenarios and so on in the future. So, yeah. So replication. There's information about the journaling system and videos and articles. Go to the Interbase Doc Wiki. And there's an Interbase Labs, which has a whole bunch of videos as well.